Get this nice and framed up. Let's start dividing. Now you see we don't have the same roundness that we had before. It's actually maintaining those hard edges. Divide some more. All right, now we've divided 3 times and we still have perfectly sharp edges. Now let's zoom in and watch what happens when we divide one more time. Okay, did you see that? I'll do it one more time. Focus on this area right here. Perfectly sharp. Divide. Now it's starting to round that over, which is exactly what I wanted. Turn off polyframe. You can see where it has, you know, these sharp edges or sharper edges that it maintained, but I wanted to have a slight chamfer. So that's how we can control that degree of sharpness on those edges. Now, as you can see, we do have some issues where we had some poles happen, you know, triangles. We have some lumps here, a little bit too sharp there, which is where we're going to go back in and grab our good friend Trim Dynamic. Go in here and let's undo that. Let's bring that value down because we want to do this slowly. And just slowly start bringing that back in. Now when I smooth things out, I don't use just when you hold down your shift and activate your smooth brush, I don't just use your standard smoothing. I'll use the alternate algorithm, which you achieve by holding shift, start smoothing, and let go of the shift button. And what that does is that uses your alternate smoothing algorithm, which won't allow poles to have anywhere near the effect as they do with your standard smoothing algorithm. Now, your standard smoothing algorithm is also very useful in the fact that if I go over here to my brush menu and I scroll down here to smooth brush modifiers, you're going to see here a little slider called polish strength, and what that's doing is that's slapping a polish on top of your smooth. Default is 5. When I work on hard surfaces, which I do quite a bit of the time professionally, I will slide it all the way to 20. And because I'm an impatient fool, I'll go down here to the weighted smooth mode. Now you'll see it has a lot of different options you can select for your smooth mode. In this particular case, what I'm going to do is go to 1. You can see 1 equals stronger. So if I want to go here, and what that'll do is that will actually just toss. You see that surface starting to, how it's not just smoothing it, it's actually, you'll see it's actually starting to polish it down. So here, go back here, we'll just kind of do that. Go back to, I'm going back and forth between my standard smoothing algorithm, which has the polish on it, and then my alternate smoothing algorithm. Now, we'll just keep on going around this whole model and taking care of any pinches and weirdness that we see. With the brushes I've already showed you, particularly like the Trim Dynamic and the 2 smoothing algorithms. Occasionally I'll come back and grab an H polish if I need to. Now, let's go here and you'll see, here's the final result. You see I've gone back in and I've kind of polished out so the edge kind of disappears you know, fairly well. See some areas I'll need to go back and polish more later on, but you can see how I've taken that edge and just kind of like worked it out to where it disappears. And in any of these models, you know, it's always a play between sharp edges and smooth surfaces, so I'm just trying to achieve a balance with that. Now we have our helmet, our base helmet. This isn't complete by any means, but this is our main portion to our helmet. So what I want to go back now and do is turn on Jason's body, turn on the helmet, and see, okay, what's our fit? Now at this point we can sit there and go in and play with lots of things. Okay, do we want it to fit tighter to his head? In general, things we can play with, because Let me turn on solo. We know these are surfaces that we cannot impede upon. Now, when most people get scanned, they will actually put on a stocking cap, which will tend to pull the hair up and back to the crown area. And we can, make a safe assumption and say that, obviously his cranium is not shaped like this. The cranium likely follows this line right through here, so we can impede upon these surfaces to a certain extent. But proceed with caution, because the last thing you want to do is go too far in and actually have it want to really press up against the skull. So let's say this is exactly where we wanted it. We can look up inside and look at clearance. Now you can see that the ears are barely pushing out through there. Now this ear tip, this outer rim of the ear right through here can easily be pushed back and fold back a little bit inside the helmet without the pain. The pain occurs when we start putting constant pressure on this cartilage. So we look in there, clearance is good. So I'd say, let's, just to be safe though, what I've done is, turn this off, I took our helmet, I duplicated it, and I went down here to our display properties and I flipped it. Now this one was just as a test. And you can, when you flip it, the use for that is to see what areas of the helmet or of the head rather are actually punching through to the inside surface of the helmet. It's also good, you can flip your model, do your adjustments in your low res, go back and forth between high and low, so where you get that comfortable medium, so that you're not just using your standard model to just kind of guess where we're pushing things in and out. You can actually flip it, get it to the exact amount of intersection you want to have with the scan data, knowing you're not pushing upon the cranium, and then your model's good to go. So from here, what I've done is exploring more of the concept on this piece. Let's go up here. Let's turn off Jason. There's more pieces to this model. Now I went in, and Nova is known for star shape. That's on his forehead. That's the main drawing point for knowing that this is Nova's helmet. So what I did was I went in using the exact same methods of masking off an area. I masked off the star. Exact same process. Extract it, sculpt and polish, Dynamesh, sculpt and polish, rinse, repeat. Using all the brushes we've used up to this point, same techniques. It goes through the exact same refinement as before. You can see here, this is what I eventually decided upon that I liked. Thought that the top folding back looked like it had been bent, looked a little bit weak, but I still wanted to have a little bit more of that aerodynamic look. So I went in and polished till I got to this point. Went back over here, grabbed my topology brush, went to town, retopologized that, and exact same process again. I'll show you. You see, went back in and assigned my poly groups, creased by poly groups, and then smoothed it. And now we have pretty close facsimile thereof of Nova's helmet as shown in current comics. Now, when you're creating these hard surface models, it's very common to have an area that's going to have a texture map assigned to it. The entire helmet is not just going to be completely slick. There are panels that may have some kind of text showing on them. There may be kind of like a scuff plate, so let's say he's on re-entry, things are constantly hitting the helmet, so you're going to have scuffs constantly coming through here, and there may be a need for a separate plate here with a different texture. So what you're going to want to do is you're not going to, if these models, since they're life size and printers have really reached the point of being able to capture ultra fine detail, we're talking like 4 to 6 microns, sometimes slightly lower based upon the printer. You don't want to have your entire model divide this entire piece up to the point of being able to achieve a texture in just a very small area. So that's where we're going to go into extracting a panel that will have that texture. so that our model, we're not bogging down the computer needlessly, smoothing to an insane degree everywhere else just for a little bit of texture we're trying to achieve in this area. Now, if you saw earlier on, turn this model on, solo. I took our original helmet model and I went in and used our Mech Cut Brush. Now, let's go over here, find my Mech Cut. There we go. Down here, stroke. Step is good, radius is good. Now, I go in here. Quickly just drag it out so you can see what it does. It's almost like, has a little bit of the pinch crease thrown in with it, because it barely deforms and barely pillows the surface around where you're sculpting, but it gives a really nice clean inset, nice clean scribe line there on your surface. It can be used just as topologically, just to sculpt the detail on there, but in this case we're going to use it to generate an extraction. All right. Now I've used the Mech Cut Brush to go in and create this panel line on our model. And what I've done is, and I'm going to go back and let's up the intensity on here. Drawing this in here. Now what I've done is I drew my line with my Mech Cut Brush. Now I went up here and hold down Control for your masking menu, and the brush is Mask Bias. That's another one that you can find on the ZBrush Central forums. And again, forgive me for not crediting the person, not knowing the person's name who created this brush, but kudos, because this is an excellent brush to use for what we're about to do. Select Mask Bias. Now what Mask Bias does, as its name states, it will have a bias towards the plane that you're currently masking on. So, see when I'm masking, I get close to that edge and you can see how it wants to stop. And I can even keep going up. And see, yeah, it wants to push a little bit there because we're not quite deep enough. But otherwise, you can see it's pretty well respecting that edge of that little plane that we drew. Go back here to Mask Pen, kind of clean it up a little bit where I kind of went over. Up here I actually did it deep enough to where I didn't have to go back and do this. That's another balance you have to do, is actually sculpting this deep enough to where the Mask Bias can do the best job possible. So from here we just went straight to an extract. And we got our basic panel. But in order to lay down a texture on here, which I will do via Photoshop, this is just an extraction, so it's it's not UV mapped. So what it is, the exact same process as before, is I went back in with my topology brush, laid out my edges, extracted that retopped model. Use the same process that we've already shown before to select our polygons and create our poly groups. Went in, you can barely see them right there, they're fuzzy. The creasing by poly groups, and so now when we divide, it'll keep that hard edge up to the point that we determined, and then it'll start to chamfer it. Same process as before, going back in with our little pinches here, using our trim dynamic to polish that back down. Let's take this back, and now our final model. You can see I've gone in, polished all that out. Okay. Now, for this model from this point on out, for the texturing, I actually just took the low res out, did a very quick and dirty UV layout in a Hedis UV. So I did that UV layout in external piece of software very quickly. And so now what we're going to do is we can't just print this out as is, because when we extracted it, what I've done is after I extracted the model, I went back in and I wanted to sit a little bit proud. So I actually moved it slightly off the top surface so that it's just slightly proud, so you can see, you know, it's obviously a different panel sitting there. But our model is actually intersecting, so we can't, we want to print this panel, and if you wanted to print this as one piece, you could print this entire helmet with these pieces intersecting, and won't have any problems actually joining the two. However, when you print something of high texture intersect with something of low texture when it comes to paint applications, the guys back in paint at wherever the shop you work at, it can be very frustrating. Yeah, they can go in and mask this off and do all their painting, but if your piece is going to be molded and cast and painted, it's better to actually have this piece actually be separate. Now, if this piece is going to be separate, you can't just go and just print them as is, because then it won't want to fit, because part of this this panel is actually intersecting the helmet surface. So what we're going to do is create an inset here into our main helmet model, so that this panel will be able to nestle in perfectly post print. Now, this would be achievable also by using Dynamesh and doing your boolean function via your Dynamesh. But the problem is that once you do your Dynamesh, you won't be able to go back in and redo any, you know, sculpting details on here, go back in between levels, because then your levels will be gone. So what I've done is I have duplicated our model, our panel here, and I have inverted the normals. The reason I have inverted the normals is because what I'm going to do, let's go up here, let's turn off the star, get this thing activated, go up here to our helmet, turn off that, and what I'm going to do is I'm have the what I called it the inset punch. I took our duplicate of our inset panel and I inverted the normals. The reason I inverted the normals is two reasons. Because I'm going to project the surface of this main helmet piece to the bottom surface of our inset panel. And so I want to make sure that that's snapping to this bottom and not to the top. And inverting your part actually helps with this. And it also allows me to see real time what's happened. So what I would do is I would go over here to project, have it be a very low value because we don't want to go very far, and we'll just say project all. Now, for the sake of expediency, go back up here, select our helmet, go down here, turn off our duplicate that we used just for projection, and actually have this here on a layer. Okay, now the reason that took so long, let's get this back up to our high subdivision level. We're going to take our model up to our maximum subdivision level, and I have gone ahead and projected this, threw it on a layer. There we go. Now you can see where we now have our inset projected on. Now, one thing I did neglect to mention, I'll go back up here and show you very quickly, is take my inset, solo, let's duplicate it. Alright, turn that one off. Is before I do my projection, you want to take into account you're going to need clearance on this piece. Because if you have zero clearance on your inset, the guys after this piece is printed, they're going to have to go back in and they're going to have to sand some of the surfaces on here in order so that it does fit. You don't want to have zero tolerance, because all these models are going to have paint put on, and you need to talk to your paint guys wherever this is going, if possible, after you're finished with it, to see what their average paint thicknesses are. Some guys will use a high build primer, which builds up pretty thick as their original coat to lay down, so that they can sand out any build lines that you may observe on the model after it's being printed. Some printers, the build lines are so infinitesimal that they'll just start throwing down paint. Minimum on here is, probably about 10 thou clearance. So what I'm going to do is 10 thousandths of an inch, somewhere between 10 and 30 thou is standard based upon my experience. So we'll go here to deformation, and what I'm going to do is I'll go down here to inflate, and an inflate of 1 at life size actually gives you that between 10 and 30 thou, which you have some leeway in there. So just an inflate level of 1, that is the model I will actually take. Then I will invert it, as you saw before, create our Inset Punch. Now when I project to this one, is what gives us the properly clearanced inset for our panel to sit into after it's been printed. So now that's taken care of. Let's go and turn on our final panel and zoom in. You can just see that little bit of clearance around there as it comes out. See our clearance, the little line of clearance right there? It looks really small, but like I said, based upon the thicknesses of paint that your paint guys are telling you that they lay on, or going to lay onto it, that should be enough. That's approximately 10 thou of clearance right there. So now texturing. Like I said, I went in and I just did a very basic texture to toss in on here. Turn that off. Okay. Now, when you're laying down texture on these models, let's do here. We have our polyframe. I just went in and laid down a very basic texture on here, something really quick and dirty in Photoshop. Let's get down here to level 1. Now, very important thing when you're putting texture on this model, you do not want to put texture on the inside surface or on these leading edge surfaces. That is because it's going to make for a really nasty projection on the bottom, and if your texture has a lot of ins and outs, it's going to be pretty hard for that to want to line up on the outside surface of the fitting that we've just projected in. So we only want to project on this outside surface, in which case I'm going to isolate select. That, our outside surface, take the subdivision level all the way up, turn that off. Now you can use obviously whatever type of texture you want, but you want to use the higher the better. Now obviously you want to use your Photoshop documents for your texture as opposed to JPEGs, because JPEGs have compression that's going to yield a pixelated result. So however, for expediency, close up these menus here, I'm going to go down to displacement. Now let us clone it. There we go. Now we're going to sit there and say mid is going to be 0.5, which is standard default on here. Now, one thing on here, your mid value is going to control how much of your texture pushes out versus how much pushes in, your whites and blacks. In this case, I'm going to have it push in as much as I push out, because I don't. This is already a thin piece. It's somewhere between the 1/16th and an 1/8 of an inch. And I don't want to make areas that are too thin that will want to carry over into mold. So I'm going to say apply displacement map. And here you can see the final result of us having applied the displacement map to the selected poly groups where we had everything else hidden here around the edges. Now let's go back and let us go to visibility, show point. Now we have the rest of our inset showing here. Let's go back up. Let us turn our helmet back on. And now you can see, you zoom in, I wanted to keep a little clean border here around the edge of our texture. And you can see our little bit of clearance, about 1/10 or so of clearance here that we created when we projected our duplicated and inflated and then inverted other panel that we created and projected the helmet into that created our little inset that we now have. You can see now it nestles in there really nice, and when you print you can be assured that this piece will definitely fit into there perfectly. Alright, let's zoom out. Let's take a look at our overall piece. Looks great. Let's go back up here and see how it looks on Jason. Everything appears to fit well, same as before. And one other thing I like to do is, and you'll actually find yourself doing it quite often when you end up doing costumes like these, is you'll have what we call a neck gasket. This will end up being a foam rubber piece that will go on. Usually we'll have a zipper that will be hidden back here in the back that will actually be kind of a bridge between the other armored pieces that will then cover up this border and going up here behind the helmet. They'll oftentimes actually also work in a form of a balaclava, like a cut balaclava, to actually be cast into this foam piece so that they can then have other straps attached to it so that this helmet can actually be secured to the talent's head. This was actually created in the exact same manner as was the helmet. Just another extraction, started on sculpting, and I will finish this out the exact same way that I finished out the helmet. So after this point, let's turn our neck gasket off. Let's go turn off Jason. And some parting thoughts on actually sending this to print. On large pieces like this, especially if you're going to be sending to PolyJet based printer, also SLA printers, the parts will continue to cure even after they come off the print bed. So as these parts continue to cure, shapes that you see here where the parts are curved, these will want to continue to cure and pull inward. And sometimes you'll actually have, if the piece has to set for several days before anybody's able to get to it for molding and casting, these parts will deform. So before anybody can get to it and clean it and use it as is or cast it, we want to go in here and just create a cube, stretch it out, and then have it bridge between these points here on the front of the helmet. I would also probably put one between here and between there. So let's go and duplicate that. And pull this out. Move this up. Now, the reason I'm going in and pulling this away, at least a 1/4 to a 1/2 inch away from this leading edge, is because if they're just going to cut this off and use the actual helmet as is, go ahead and paint it, then it's not that big of a deal. You don't want it getting close to that edge, so they don't have to worry about having to do any edge repair physically. They can go in and just snap this off, cut it off, and sand this down flush. However, oftentimes they have to make multiple copies of a helmet because you'll have what's called the hero helmet, which will be the one that gets all the TLC, all the scratches are put on physically, all the detail is sanded down. It typically will be a hard helmet cast in fiberglass. But then you'll also end up having a copy which is for stuntmen, which need to be softer so that when they take those blows and hits and fall, that they're not going to get injured, and they know that this helmet is actually not going to break and actually cut off sharp and end up cutting them. So in order to prep this piece such that it can easily be cast right off the printer, you will actually want to have a return here, I said, of between 1/4 to 1/2 inch before you have these cubes placed in there. Because what that's going to do is, on set, whenever you have these helmets, typically on a return on the inside of a helmet, you'll only see between 1/4 to 1/2 inch in. And so this kind of keeps them from having to worry about any marring on the surfaces that you're actually going to see on screen. So when they go in and cut this off and then have to sand that, it's not going to be visible. Because when the guys in mold are going to get this piece, what they're going to do is they're actually going to go in and they're going to actually take some styrene or some clay, and they'll actually backfill this entire area so that it can actually be done in a multi-piece mold. So having these set far enough back lets them know how much return you're going to need. So we've already done that one. Let's duplicate again. Move this up. Move this back. Scale this in. There we go. And we've got our support there. And you would also probably want to duplicate again. Have one right here in the nose area. There we go. Now, you can see here, it doesn't touch the edges. That's not that much of a concern. But we can still go here and pull that out. No need to be concerned if these end up getting a little bit warped or deformed, because as I said, they're going to be ground right out. There we go. Now we have adequate support in there to make sure that this piece actually has to be left for a period of time after it's printed, that you're not going to end up having deformation on your model either during the molding and casting process or in the period of time between when it comes off the print bed and when then it's actually handled by the next person in line that's going to finish it after you've finished your part of the process. Alright, so that pretty much wraps everything up. A couple last quick concerns that you may have is that when you send this to print, is that to always be cognizant of your overall print size that you're able to send, which is why we went up here and created this separate textured piece so that we could pour all of our texture onto this one surface and not the entire model. Go up here. That when you're exporting these parts, it's great to really make use of Decimation Master to target your file size to whoever the service bureau you're going through, or if the studio you work at actually has 3D printers, to be able to target your file size for what their needs are. You obviously want to squeeze as much out of that printer as you can. If they tell you that it can handle 300 megs, I personally will try to keep it as close to that as possible, because I'm definitely a fan of the idea that if the printer can handle it, why not send it? So that wraps it up, and if you guys have any questions whatsoever about anything that I've covered here in this tutorial, please feel free to contact me on the ZBrush Central forums. My handle is PoBoyRoss, POBOYROSS, or you can also contact me via my personal email, which is idolworkshop@gmail.com. That's idolworkshop@gmail.com. I'm more than willing to answer any and all questions you have as it relates to RP, getting your parts to print. If you'd like a set of those quick cubes that are marked for your measuring your tolerances, I'd be more than happy to send you a set of those as well. So thanks guys for tuning in, and happy ZBrushing.